to welcome Flavio to the unit. We've been trying to arrange time to get him over here to give us a talk for a little bit. And so I can't remember, when did you join the Faculty of Economics?
2005.
So you have been here a long time, because I know you're a fellow of, well, not as long as some other people who've been here forever. So, but you're also a fellow of Clare, and you was going to give a talk that was very, very focused on your current research interests, but they're quite broad. And I said, we don't know too much about economics, and could you keep it broad and general so that we learn, because most of us aren't particularly interested in the specifics of infectious disease, but we are interested in how economics and the study of it relates to public health and public policy. So it was really great for you to come over and be accommodating to my whims about what we should and shouldn't talk about. So thanks for that, because not all speakers are like that. So it was really great, and thanks for making the effort.
Thank you. Thank you very much for having me. It's an unusual thing for me to speak to an audience like yourselves. Usually I speak to economists, which means I could take a lot of stuff for given about the economics of it, but I have to kind of convince them that infectious diseases are important. I take it that here it's going to be the other way around. The challenge is going to be that to try to argue that economics is actually important in this context. Let me just for completeness point out that I'm no longer affiliated with the CEPR, but that didn't get picked up in the slides. All right. So indeed, what I'm going to do today is to give you a kind of a broad idea of what economics can contribute to the field of public health. I suspect that you have your fair share of preconceptions about what economists do, and I hope to show you that it might not just be about dollar signs, all of it. It's more about thinking about behavior, thinking about incentives, and try to use those insights or the toolbox of economics to make sensible decisions in the space of public health. So let me just start by motivating why this is an important field of study. So 14th century Europe, the Black Death claimed an estimated 25 million lives out of a population of 100 million. So basically a quarter of the world's population was, or rather the European population was wiped out. 1918 to 20, there was a flu epidemic centered around Russia that claimed, again, of the order of 50 million. These are historical estimates, are very, very, very imprecise, but these are kind of the orders of magnitude that people have estimated. And lest anyone think that this is mostly of historical interest, there have recently been, of course, the ongoing HIV/AIDS epidemic has claimed now 25 million lives. We've made great, great progress in managing HIV and making it a chronic disease. So that is a disease you die with rather than die of. But this is, of course, after already having had a double-digit people dying of it. I don't want to overemphasize just the deaths, because the kind of model I'm going to look at today is one in which people get infected and the infection is undesirable, but is not actually a model in which people die. So let me just point out that there are lots of side effects of getting infected short of dying that are very, very undesirable, such as loss of mobility, fertility, lost earnings, and what have you. Okay, and also with a view to the future, we know that there are new epidemics coming all the time because infectious diseases mutate over time, and so there are new versions coming. And God forbid, of course, we also know that there might be design diseases that are intentionally placed in the population with a malicious intent. So this is something that, as a topic of public policy, we really would like to get a grip on how to best deal with this kind of situation going forward. It turns out that many of the issues that pop up when looking at infectious diseases are very, very familiar to economists, and that's why the field of economic epidemiology has emerged, because it turns out that some of the issues we've already thought about them very carefully, but in other contexts. And so what we are trying to do in this subfield is to transport some of these insights from the realm of economic thinking and using it in the context of infectious disease control. So that's, in a nutshell, what economic epidemiology is about. Okay, So just to give you a little bit of a historical perspective, most people, when I mention economic epidemiology, they think I've misspoken because they don't think of them as being really within the same sort of intellectual tradition. Although, let me point out, there was a very early point of context. Daniele Bernoulli, who was a polymath and mathematician of a very prominent family of mathematicians, was the first to write down a mathematical model of the propagation of an infectious disease. Turns out he was also a very early contributor to economics, making important contributions to utility theory. But even leaving that aside, if you look at what is the traditional textbook reason given by biologists and epidemiologists of why we're interested in studying infection control and infection propagation, is very much a public policy type thinking. It's not just we're interested in these as biological systems, which of course we are, but also we would like to understand them in order to do something about it. Okay, so let me just give you an example of Bernoulli's original paper. He just says that I simply wish that in a matter which is so important for mankind, we should make no decisions or any policies without availing ourselves of all the benefits of having some analysis and calculation. So this is almost an invitation to try to model infectious diseases in order to do good. And then more recently, this is a standard text on mathematical epidemiology. There's no economics here still. One of the purposes of modeling epidemics is to provide a rational basis for policies designed to control the spread of disease. So you can see that the policy issues are really very much floating around when we try to figure out why we want to understand how infections spread in populations. Okay. Now, the classical approach to epidemiology that is clear in these texts is very much one that is devoid of behavioral considerations. And the reason for that is partly to do with the tradition of the discipline. Many of these studies were very much about animal populations. So, for example, you have a herd and you are the owner of the herd and you want to control it. But of course, there's no sense in which the cows make decisions about, say, fleeing from each other and trying to avoid the infection, or wearing condoms or something like that. Okay, of course, it doesn't make any sense in that kind of context. Not for a cow, right? But once you use these kind of models on human populations, incentives now become very important because we know that people actually make decisions that can influence the disease. And so blindly transporting a mathematical model that is designed to look at animal populations may not be appropriate once you look at human populations. And once you take behavior into account, that's where the force or strength of economics comes in, because at least it's purported to be a discipline that looks at people's incentives and their constraints and then their behavior. Okay, so that's exactly where it comes in. So just to convince you that behavior is indeed important, there's this famous book, Decameron, that I read in high school by Boccaccio, which was the story of people who have fled the plague, and they were sitting in some beautiful castle up in the hills, telling stories to each other. And you can see here that the Black Death made people shun and flee from the sick and all that pertained to them, and by thus doing, try to get immunity from themselves. This is just one instance in which people do something in order to change their probability of becoming infected in the first place. Okay, so there is clearly a role in individual decision-making in the overall propagation of disease. But by the same token, the overall propagation of disease in the population will also influence what individuals do privately. So there's going to be an interplay at what we can call the micro level, that is at the level of the individual, and what we can call the macro level, which is what happens in the whole population. Now, it turns out that the dichotomy between micro and macro, that's the bread and butter of economics. So, for example, you want to know, what does an individual consumer do? How much does he or she want to buy of something? Where do they choose to live? How many hours would they like to work? Those are all decisions of the individual decision maker. Those will be informed in part by what is the general state of the economy. What are the prices? What's unemployment? What are the house prices like? And so forth. So the individual decision is influenced by the aggregate, but by the same token, all the individual decisions are the ones that make up the aggregate. So in order to understand what happens at the population level, we need to understand what happens at the individual level and vice versa. Okay. So just a last picture here. This is, I think this is some underground. I don't know exactly where it is. This is just another instance of where somebody has taken precautions not to, I can see there's somebody here doing the same. So this is just another example where individuals make a decision that might influence the propagation of the disease. Okay, so so this is going to rehash what I've said already. Let me just give you a very quick outline of what I intend to do. So first I'm going to give you the very simplest model of mathematical epidemiology, and I'm going to do that without any math at all. Okay, I'm just going to show you a picture, and I'm going to talk you through what that model does. And once you understood that, I will go through what we call the economic version of that model. It's going to be a very simple epidemiological model, but it'll be one where it's coupled with individual decision making and optimizing behavior. Once I've done that, I will talk about interventions and optimal policy, and I will talk about something called decentralization, which is basically the idea, or rather the question of whether one can implement desirable outcomes just by instructing people to do the right thing. Okay? So that's what the decentralization question is about. Okay, so in the interest of time, let me skip the related literature. I will distribute the slides, and so you can look all those up. Okay, so the classical, one of the simplest models in epidemiology is called the SIS model. The SIS model stands for susceptible, infected, susceptible, and that captures the standard cycling of an individual between different states of infection. Okay, so at any given point in time, there's going to be two kinds of people in this population. Either you are infected and thus infectious, or you're non-infected. So if you wish, you can think of something like syphilis, or you can think of athlete's foot, or what have you. It's just something that once you recover, you are now susceptible again to new infection. Okay, so this clearly does not cover all diseases, and the devil is in the detail. HIV, for example, is not an SIS disease, because at least until very recently, there were very few examples of people recovering and then not being susceptible. So that is an SI because you're susceptible, then you're infected and you stay in the infected class. Okay. Then there are other diseases that are much more complicated to study called the SIR diseases. The common cold is an example of that. That stands for susceptible, infected, recovered, or removed. In those models, you typically have something called herd immunity, which happens when enough individuals become no longer susceptible to infection. And that throws up a whole host of different questions that are interesting, but which I will not have time to cover today. Okay, I have a paper on that, which was the original intention to present, but it's on my homepage if you're interested. Okay, so at any given point in time, a given individual is in either of two classes, okay? And what we will have is we will have all these individuals meeting each other, you know, at the workplace, in the buses, what have you. And these contacts are the ones that potentially transmit the disease, okay? And what we will assume in the basic model here is that there's going to be infection through contacts, but then there's also going to be spontaneous recovery. So at some point after a spell of infection, you're going to spontaneously recover from the disease, and you're going to transition back into the susceptible state where you can then again be infected through contacts with infected people. Okay? Okay, so this model, the standard epidemiological model has, oh, I should say, by the way, I'm more than happy for you to interrupt me during the talk. You don't need to wait until after I've stopped speaking. I'm happy to have questions up front. So the standard SIS model has two basic parameters. One is called beta, which captures the infectiousness of the disease. It basically tells us how bad is this in terms of probability of transmission. And this is something that people go out and they estimate for different diseases. So for example, it's well known that, say, this disease has a beta of 5 and so forth. Okay. There's going to be the other parameter, which is the, we're going to call that alpha, is going to be the rate of spontaneous recovery. So if alpha is very high, then that just means that you're very your spell of infection is going to be relatively short. You're going to transition back to susceptibility very fast. That's what that means. Okay, and so let me show you diagrammatically. So you as an individual, you can be either susceptible or infected. Okay, and then if you're susceptible, you may become infected, and the rate at which that happens, okay, at the aggregate level, at the population level, is given by this expression. So think of it this way. I of t is going to be the fraction in the population that is already infected at this point in time. So that could be either 0 or all the way up to 1. So think of that as being the probability of meeting an infected individual if you were to go out and just at randomly contact one person. Now, once you've met that individual that is infected and you're susceptible, then you will become infected at a rate beta. So beta times I, you can think of that as the force of the infection or the risk of becoming infected. Now, how many people are potentially infectable in the population? That's S. So this gives you the aggregate number of new infections at a given point in time. Down here, we have the infected people who are recovering. How many are already infected at this point in time? I of t, that's the fraction of the population that is infected. And of those, a fraction or a rate alpha will recover. So that accounts for the flow back from infection to susceptibility. Okay? So just with a preview to the economic model, once we get to the economic model, what we're going to do is we're going to look at two instruments. One of them, we're going to call it prevention. And prevention is going to work by reducing this rate. And we're going to look at treatment, which is going to work by increasing this rate. So people who are infected, we treat them and they recover faster. So that's the basic idea.
Does the model not allow for any interplay between infection and subsequent susceptibility? There's plenty of diseases where
Absolutely.
you might be resistant to recurrent infection, or other ones where the host might be weakened by having infection.
Yes.
Therefore more susceptible.
So this is the cartoon version that is taught in all epidemiology textbooks. So this can be incredibly complicated. You can have deaths and births. You can have flow into the population. You can have many states of infectibility. So, for example, in sexually transmitted diseases, for example, women are more susceptible than men. So you can have several classes of agents. You can also play around with the contact patterns, where you're more likely to meet some types of individuals rather than other types of individuals. You can have latency periods where you get infected, but you're not infectious for a while. There are all sorts of complications that you can add to the model. So yes. Okay, so that's the SIS model. And just let me give you what is the result in this model. So the result is that if alpha is larger than beta, that means the rate at which people recover is higher than the rate at which people get infected. Then over time, there's going to be fewer and fewer people in the population that are infected. And eventually, the infectious disease is going to die out on its own. Okay? Even if we don't do anything. And by the same token, if beta is larger than alpha, that means if people become infected at a higher rate than which they recover, then overall, there's going to be more and more infections over time, and the infectious disease is going to be endemic in the population. So, for example, athlete's foot is a great example. Okay, it is an endemic in the population because it's a highly infectious relative to the rate at which people recover from it. It's just very, very difficult to get rid of it. So that's an example of an endemic disease. Okay. Okay. So this picture just shows you the evolution towards one steady state. That is a steady state that is endemic, and this is a steady state where the infectious disease dies out over time. Okay, so this is, until now we've had purely a biological model, there's no economics to it. So the next question I want to ask is, well, suppose we want to do public policy. We have this disease out there. We want to figure out what is the right thing to do. How much should we spend on eradicating this disease, say, or controlling it, okay? And the problem is that the standard biological model is not a very good vehicle for that because it doesn't assign any values to it. We don't know whether it's worth our while to combat a specific disease. Okay, so for some people that might be controversial, but let me just give you a very stark example where I'm sure you'll agree with me. Suppose that we could eradicate athlete's foot, but in order to do that, we'd have to spend £1 trillion. Okay, of course, this is a very stark example. I think you'd all agree that that's probably not money well spent on eradicating athlete's foot. Okay? If I now were to say to you, let's try to eradicate HIV for that same price, then we might start thinking that that is a sensible proposition. Okay? But once you've agreed with those two propositions, you will agree with me that there are some things that are worse than other things in terms of diseases, and there are some that are more worth of our effort than other diseases. And once you start thinking that way, you're basically thinking like an economist. Okay? So what we're going to do is we're going to turn the model into an economic model by making a few assumptions in addition to what we already had. The first one is going to be that there's a welfare loss associated with being infected for the individual and hence also for the population. Okay, so what I'm basically proposing to you is to view infection as being undesirable, and the way we're going to model that mathematically is to say that there's a well-being that has a number attached to it, and when you're infected, that number decreases. And I'd like to stress here that this is not necessarily a monetary cost. This is not a matter of pounds and pennies. This is a matter of pain, discomfort, lost earnings, social stigma, anything negative that you can associate with being infected. We are going to associate those with the cost of being infected. Okay? And what we're also going to do is we're going to look at these two particular interventions that I mentioned, which is on the one hand prevention, and on the other hand treatment. So prevention and treatment are going to work in the model through changing those flows within the SIS diagram. Importantly, we're going to make the assumption that intervention is costly. It is costly to treat people. It is costly to prevent the infectious disease. Okay? So for example, each time you want to treat a given disease, you have to give them a shot of antibiotics or something like that. Each time you want to reduce infection, you have to either put quarantine measures in place or distribute condoms or what have you, depending on the specific infection. Okay, so let me just run ahead to the picture, and then I'll come back to this slide there. So I'm going to take you through first prevention, and then I'm going to talk you through treatment, and I'm going to show you how they might, even though they might look as being very, very similar types of interventions, it turns out that the optimal policy, when you have those two instruments at your disposal, are radically different and for quite interesting reasons. So let's look at first at prevention. So in the prevention world, we are back in our SIS diagram. The recovery here, since there's no treatment, is going to be just a spontaneous recovery that is determined by biology. Then there's going to be newly infected, and what you will see here is that I multiplied beta with something called phi. And phi, just think of it as an instrument that can take the value 0, 1, and you can think of that as exposure. Okay? So if you choose phi equal to 0, that just means you're preventing the disease from spreading from person to person. It's like saying we're going to reduce contacts down to 0. And that means by definition, you can't have new infection. Okay? Whereas if phi is equal to 1, you're basically back in the old world where everybody can become infected like before. Okay? So let me, before I go into the details, let me go back to this diagram, but now with prevention. Under prevention, we don't do anything about exposure now, but we're just looking down here. And down here, I've now multiplied the alpha parameter with something called R. And you can think of that as being the speed with which you induce recovery. So, for example, if you put in a lot of effort in treating people, you will have a very, very high value of R. And so the number of people who flow from being infected to being susceptible is basically boosted through this intervention. Okay, so now that I've shown you the ideas, let me go back a few slides and talk to you about economics. Okay, so one of the first things that students in economics learn, and is one of the most fundamental ideas in economics, is the comparison of marginal benefits and marginal costs. And I will take you through the diagrams, and there's nothing complicated about it. Okay, the idea is basically that whenever you make an activity, you do something, you have to make a decision as to whether you would like to do more of that or less of that. And the way to make that to determine what is optimal to do is to compare how much extra do I get from doing an extra unit, and how much does that extra activity cost you. Okay, so that means that if you're deciding whether you want to treat more or to prevent more, you're going to basically say, well, what's the marginal benefit of treatment and what's the marginal cost of treatment? And if it turns out that the benefit of treatment is higher than the cost, the marginal cost, you would want to do more of it. If it's the other way around, you want to do less of it. And if they're exactly equal to each other, then anything will do. Anything is equally good. Okay? So let me show you the diagram and talk you through the details. Okay, let's start by looking at prevention. So on the x-axis, what I have here is disease prevalence. Okay, so that's basically the fraction of the population that's already infected. That can be all the way down from 0, all the way up to 1. That means everyone is infected. The horizontal line is the marginal benefit of prevention. So what does that mean? Suppose you want to prevent infection of one individual. How much would that cost you? Okay, that would be that level. So if you want to think of it, to fix ideas, think of the cost of a condom. Okay, so suppose that a condom costs £1, and so that's this level. Why is it flat? Well, because this is the additional cost of preventing one more person from being infected. And so if the price of condoms is always 1, the first one it will cost 1, the second one it also will cost 1, and so forth. So it's not the total cost, because that would of course increase. It's the marginal cost. Okay, so that's a constant. Now the marginal benefit of prevention turns out to be an increasing function of prevalence, and that's interesting. Let's try to unpack why this might be. So suppose you're about to engage in some kind of interaction that is potentially risky. Okay, you can potentially become infected, and you're asking yourself, if I use this preventive measure, say the condom, you can avoid becoming infected. Okay. Now, if no one is infected in the population, how much bang for the buck do you get from actually protecting yourself? Well, it's going to be negligible, because almost no one is infected in the population. And so the probability that the person you're with is infected is going to be very, very small. Okay? So for example, just to give you an example, suppose that there was only one individual in the whole universe that had HIV. And you're asking yourself, what's the probability that the person I'm with tonight is that one person? It's going to be negligible. Okay? So that means that the benefit of protection is going to be very, very small for low levels of infection. Now let's go to the other extreme. Suppose you are somewhere, there are some countries where there are double-digit probability of meeting an infected individual. That means that if you're now not protecting yourself, your probability of becoming infected is going to be extremely high. So the value of protecting yourself now is really very significant. And in any case, surely higher than the cost of the condom. Okay? Now, let's see what the consequences are of that. There's going to be a point at which these two curves intersect. Okay? Suppose you are to the left. So just to remind you, if you're to the left of that intersection point, you are at a point where the cost of the condom is relatively high relative to the benefit of using the condom. Now, if the cost is high relative to the benefit, you're probably going to say to yourself, it's not worth my while. It's just not, the risk of getting infected is negligible, and so I'm not going to use the condom. Okay? What happens then? Well, if everybody thinks that way, there's going to be lots of people who actually become infected. Well, not lots, in the beginning some, but people are going to keep saying this little, this reasoning is going to be valid all the way up to the intersection point. So down here, almost no one is infected, but some are. Everybody is having, are exposing themselves because of this reasoning. That means some of these people are going to get infected. What happens then in the next period? Well, there's going to be a little more infection and so forth. And so this reasoning is going to push infection all the way up at which point, until the point at which the marginal benefit equals the marginal cost. And at that point, people are going to wake up and they're going to say, oh, hang on. Now there are significant risks of becoming exposed, of becoming infected. And now I'm going to start using the protective, say, condoms or what have you. Yes?
So you're talking about cost and benefits.
Yeah.
They're conceived in our minds as in the same unit. Because the cost of a condom is £1 and the benefit is conceived
You're
in
absolutely
a different way. So I'm just wondering how you're...
So I am. You're absolutely right. I'm making them to comparable units. So this is not an uncontroversial thing. There's a big field in economics that tries to elicit people's willingness to pay. For example, what is the premium that you have to be paid in order to work in a mine, knowing that you're going to have a deteriorating health and so on. So there is an active research field that tries to make sense of these kind of comparisons. But let me just point out that we're actually making those decisions daily, right? You're deciding to go to work, presumably because of the benefits, but you're also exposing yourself to risks in the traffic, right?
So that's what I was thinking. Rather, I know about and so on, how you monetize and so on.
Right.
But that's not how ordinary people. That was my question.
That's not so clear. So one of the things that I skipped, there's a whole literature looking at. Maybe I should I go back? Let me just. Okay, there's a whole literature that looks at what is called prevalence elasticity of protective behavior, and there's convincing evidence that as the amount of HIV in the population goes up, people are more prone to using using protection. So as a matter of fact, they seem to be responding as if they solved this problem, but I'm going to be agnostic about how exactly that came about in some sense. I'm just saying.
So there is some changes.
That's right. Yeah. Yes, please.
The marginal benefit, does the gradient of that vary depending on how, if the disease is fatal if you contract the disease, or is this only for actually contracting?
Well, okay.
About the severity?
That's a great question. So first of all, remember in this model nobody dies, but let me but even if they die, it's going to be the same shape, but maybe not the exact same location. So here the risk is basically of a shortfall in utility, but that shortfall in utility could be infinitely large for all practical purposes. Yeah. Yes.
I'm kind of said my question is the same as Martin. It seems to assume some perfect information scenario, or that we're not variable in our perception of risks and benefits. Is that the case? Or
so in this model, which is the simplest possible, everything is known to everyone, right? So I have another piece of work where I play around with this idea, saying you don't know whether you're infected and you don't know whether your partner is infected. The only thing you can observe is whether there are symptoms or not. But you could, of course, be infected without showing symptoms. And then you have a very complicated inference problem where you have to make decision over time, having incomplete information about the state of the world. That is, whether you are infected and your partner is infected. So in this very simple version, there's no issues of information. Okay.
But you also treat everyone equally.
I'm doing an infinite number of heroic assumptions here. I'm completely on board with that. But I will show you that it becomes plenty complicated even without making all those bells and whistles. So the research that is behind this, I have one central paper, which is with Bob Rowthorn, who's an emeritus professor at the faculty. We have about 100 pages of solid maths just to solve the version where everybody's the same, everybody knows everything, and so I'm not dismissing those as being not reasonable concerns, but the point I want to make here is very, very simple, and for that purpose, this vehicle I think should do. Okay, so we covered what happens down here. What happens up here? Up here, we have a very, very high risk of being infected. So up here, people are going to say, it's simply too risky not to protect ourselves. What are we going to do? Well, the benefits are very, very high relative to the cost. And so here, we're going to protect ourselves. Now, if everyone protects themselves, that is, if everybody reduces their exposure, then there's going to be no new infection, okay? But remember, some of the infected individuals are going to be recovering because of the spontaneous recovery that was in the background. Now, those people mean that over time, there are going to be less and less people who are infected because the people who are susceptible don't expose themselves, and the people who are infected recover slowly over time. And so little by little, we're whittling away at the stock of infected individuals, all the way down to the point at which you reach marginal revenue, or marginal benefit equal to marginal cost. And at that point, people say, oh, hang on, now there's no longer such a risk of infection. Now I can maybe ease up a little bit, okay? So what's the upshot of this? The upshot is that we're going to, and again here we have on this axis from 0 to 1 being the fraction of the population that is infected. There's going to be the optimal thing to do for low levels of infection is to not prevent infection. For high levels of infection, to prevent as much as you can. And that forces the system towards an interior steady state, okay, which I've shown in that way. So we don't eradicate the disease, but also we don't let it get out of control. Okay, so that's prevention. Let's look at treatment now. It turns out that treatment is very, very different, okay, and for interesting reasons. So again, the treatment, so the treatment was basically playing around with the recovery rate. Let's look at the diagram of the treatment. So again, on the x-axis, we have number of infected people from 0 to 1. We have a flat line here that gives us the marginal cost of treatment. You could think of that as the cost of an antibiotics cure, or something like that. And then we have the marginal benefit of treatment. Now, maybe you didn't notice it, but let me just go back one slide. This one is increasing, whereas this one is decreasing. The marginal benefit of treatment is decreasing, okay? And that turns out to be a huge difference. And let me try to unpack why it is a decreasing function. And the way to maybe best understand that is to look at this slide. Suppose you are an infected individual. So you're currently here, and you ask yourself, should I treat myself, yes or no? Well, there are two reasons why you want to treat yourself. One of it is that you want to escape being infected currently, right? If you treat yourself, you will no longer be infected, and that's going to give you a boost of well-being. You're no longer infected. Infection is an undesirable thing. So that's one reason. Now, the value of having recovered, that is, of having made this transition, is proportional to the time that you will spend in this state after having recovered. So let me give you an example. Suppose that you have an infection and you can pay money to be treated, but I tell you that in half an hour you're going to be infected again. You're going to think twice. Was it worth it if it's just half an hour? Whereas if I say to you, you're going to be treated and then you're going to be healthy for a long time, maybe potentially for the rest of your life, then of course that's much more attractive. Okay? So the first point to note is that the longer you expect to have been recovered after having treated yourself, the more valuable is the treatment in the first place. Now, the second observation is, how long are you likely to stay in the recovered class, in the susceptible class? Well, that depends on the state of infection in the population, because that determines your reinfection probability. In other words, if you're in a world where there's a lot of infection floating around, if you treat yourself today, you're very likely to be reinfected tomorrow, because there's just so much of it. Whereas if you're in a world where there's almost nobody who's infected, then if you treat yourself, you have very, very low risk going forward. And that's exactly what is captured in this diagram. For very low levels of infection, the benefit is very, very high, the marginal benefit, because the reinfection probability is negligible. Very few people are infected. Up here, almost everyone is infected. Let's go to the extreme. Suppose there's 100 people in the population, okay? You and 99 others, you're going to treat yourself today. That means that tomorrow, you're going to meet infected individuals for sure, because they're all infected apart from you. And so therefore, your reinfection probability is going to be very, very high, okay? So let's just see what are the consequences of these insights. The consequences are that for very, very low levels of infection, everybody will find it in their own best interest to treat themselves as much as they can. Now, when people treat themselves as much as they can, over time, we won't just have spontaneous recovery, we will also have boosted recovery through treatment. And so over time, there will be fewer and fewer people who are infected. And eventually, we'll be in the best of all worlds, we'll eradicate the disease. Okay? But by the same token, if we were to start over here, there's a lot of people who are infected, the benefit of treatment is lower than the cost, then people will not treat themselves. Over time, there will be more and more and more people who are infected, okay? And the more people are infected, the less valuable does treatment become. Because this argument is just reinforced because of the additional infection. And so you can see that it becomes lower and lower and lower the benefit, okay? And so what happens is that if you start in a situation where you have a high level of infection, the optimal thing to do from the perspective of a social planner is just to give up here. That might be the case of athlete's foot. I mean, Theresa May could say tomorrow, we're going to spend 35 million a week on athlete's foot treatment, okay? They could do that.
Only if we get some money back from you.
That was the ones I was thinking of. Those are exactly the ones I was thinking, right? But we all agree that that's probably not the right use of resources, because the costs, the welfare costs of athlete's foot are very, very negligible. Okay, so we just say, okay, fine, just let it go. Okay, whereas if we were down here and we had one individual with athlete's foot, then society will say, okay, there's just one individual. If we treat that one individual, we'll be rid of it forever. That surely is worth it, right? Because then it won't actually spread in the population. Okay, so I have very little time left. So let me just tell you what happened. So let me talk about decentralization, okay? So let me talk about decentralization, and I'll do that by showing you two graphs. Okay. So what does decentralization mean? I've just argued that depending on whether you want to treat or you want to prevent the disease, there is an optimal policy that tells us at which state of the epidemic do we intervene and how do we intervene, okay? Now the question is, suppose that so one way we could accomplish that is to say to people, the infection has now reached, let's say, a quarter of the population. Now the best thing for you to do is to prevent any further infection by wearing condoms, say, okay? Now, as I'm sure you'll agree, just because a social planner might announce this to the population, that doesn't necessarily mean that it'll happen, right? People don't do what they're told. Okay, people make decisions based on their own costs and benefits, their own trade-offs, their own incentives. Okay, and so just because we've identified what would be desirable from a social perspective, there's no guarantee that individuals, if left to their own devices, would actually implement that same that same outcome. Okay? So the question then becomes one of trying to determine whether individuals would find it in their own best interest to do what they're being told to do. So for example, everybody agrees that we should not take the car for small journeys. Everybody agrees on that. But yet many people do anyway, because there's misalignment between the social welfare of the population and the individual welfare. So private decisions and public decisions don't necessarily align well. Now, it turns out that in the context of infectious diseases, this is particularly striking. And the reason is because of an externality. Is externality now something that has permeated outside of economics? Yeah? Okay. So how does it manifest itself here? It manifests itself in that when I make a decision as to whether I want to prevent myself becoming infected, I may not factor in the fact that I can infect third parties. So I might protect myself because I am afraid of becoming infected. Okay? But of course, if I don't become infected, I don't infect third parties. And even if I'm somewhat altruistic, I might not be perfectly altruistic. And so it's not going to be one-to-one. It's not like you make decisions based on the entire population. You do it mainly based on yourself. So that means that from a social perspective, the value that an individual would assign to prevention is going to be lower than what the social planner would assign to prevention. An individual will say to himself or herself, what is my cost of prevention? What is my benefit of prevention? And in doing that comparison, they will not perfectly take into account the benefits that other people have from my actions. And mathematically, that translates to a shift downwards in the benefit curve of prevention. So that means for each level of infection in the population, an individual's value of the prevention is going to be lower. Now, that means that the intersection point is going to be higher, okay? And the interpretation of that is that the shift from not preventing to preventing is going to happen at a higher level of infection. That is, the social planner, if you start down here, infection increases. When we get to this point, the first intersection point, the social planner will say, oh, now people should really stop. They should really start using condoms. But the individual is going to say, for me, it's not worth it yet. I'm going to wait a little bit longer, and we're going to get up in that situation. Okay. So what happens then is that the steady state or the prevailing, the endemic level of infection in the population is going to be higher under decentralized decision making. That is, when people make decisions on their own without a view to benefiting society as a whole, than it would have under a command economy where the planner just says, now you all wear condoms and we can actually make that happen magically. Okay, so that's prevention, and you'll be not surprised to learn that something very similar goes on in the world of treatment. We value treatment less, and so what happens is that the intersection point here in a decentralized world where people make decisions on their own account are going to be lower than the intersection point on your social planning. And so that means that remember on the treatment, you give up for high levels of infection and you do your bit for low levels of infection. So that means in this interval, the individuals would give up because they give up for anything that is higher than that level, whereas the total planner would only give up for levels above that. So if you are in here, the social planner said, it's still worth, so, the house is burning, okay? And the social planner is saying, there's still enough of the house left for it to be worth our while to fight this thing. Let's put out the fire. Individuals say, it's already too late for us because they don't internalize the fact that everybody else is hurt, okay? So the big takeaway from these two last slides is that externalities are not necessarily properly internalized by people, okay? And that causes people to do less than what they should do, okay? So I don't know, if you have a child, the child vomits, you have to wait 48 hours before you can send the child back to school. Okay, but after 1.5 days, there's been no vomiting. Surely it's all right. Surely they're not infectious really, right? And it's so massively inconvenient. So you send them back, okay? And you're not really thinking of the fact that all the other parents are now slightly more likely of having the same problem a few days hence, right? So that's the idea. Now, how can we solve this problem? It turns out that we have nice tools for that kind of thing, and they're called Pigouvian taxes, or subsidies. So Pigouvian subsidies, named after Arthur Pigou, who was a colleague of ours in the Faculty of Economics many years ago. So he basically had the idea that you could price in the externalities and make people do the right thing by paying them to do the right thing. So one thing, for example, would be to distribute condoms freely, so that rather than having people pay out of their own pockets, they have easy access to these things. Okay, so that's one way of doing it, and this is something that has been used in the context of vaccines. So vaccines, many of them you can get for free. There are also negative Pigouvian taxes, which is to say, rather than paying people to do the right thing, we're going to punish them for doing the wrong thing. And how could we do that? Well, in Australia, for example, if you don't have a vaccine, you can't send your kids to public schools, or not public schools in our sense, but in state schools. Okay, that's another way of saying, we're going to really make your life miserable if you don't do the thing that is good for everyone. So this is one way of trying to get at this problem with externalities. Now, we had fun with my co-author trying to figure out about actual implementation. So, for example, suppose that you give people free condoms. That's going to give you a little bit of boost of use of condoms, right? But just because you distribute them doesn't mean that actually people use them. So it's very difficult to actually control people's direct use. Okay, that would be slightly intrusive. You get the point, right? So just making it available doesn't mean they're going to be used, and so even if you have identified an externality, doesn't mean that you can actually act on it and solve the problem. Okay, I think I've almost overstayed my welcome, so let me just leave you with this quote, which very nicely encapsulates the discipline that I'm contributing to. So this is a few years old, but I think it's still valid. So this is Gersowitz and Hammer, who wrote one of the early papers. They said that economic approach to infectious diseases is still in its infancy. And this is somewhat odd because many economists have long had the intuition that epidemics and infectious diseases are quintessential manifestations of the principle of externality, which is, of course, a central concept in economics. Furthermore, epidemiology provides ready-made dynamic models of disease transmission, which is the standard epidemiological models that you learn in any course on public health. And economics provides an entire toolbox to do optimization or to do public policy within dynamic models. Okay? Yet only recently have economists begun to look at these questions in a formal way. So since this quote has been written, there's been a whole bunch of theoretical work like what I have contributed to, but there has also been a very, very large literature now looking at randomized trials where people go. So, for example, there's some wonderful work that has been done by researchers where they go up and they play around, for example, they see what are the consequences of increasing people's knowledge about infection. So, for example, they say, infection rates or risks are so and so, and then they basically record what people do. And interestingly, that can backfire. So many people are under the misconception that it's very, very likely to get infected with HIV. It turns out it's extremely unlikely. There are very few people who have disease, and even if you were to have unprotected sex with an infected individual, even then, it is very difficult to get it. Okay? Now, what would the consequence of informing the population of that be? Well, it would be that people are going to be less afraid, and hence there would be more infection. So there's some interesting set of issues there in terms of policy of what is the right thing to do. It's not necessarily to inform people of the truth. Maybe it's okay that people are slightly scared because it keeps them on their toes. Okay, but that's just one of the many nice things that is being done in the literature. Okay, so I think I exactly hit the hour. Yeah.
One of the reasons I was keen in the UK was,
You changed your mind now.
No, actually quite the opposite. Actually. So, economic epidemiology, I can see why it has its origins in infectious disease, because it's so easy, relatively speaking, to think about externalities and how you might manipulate people's perception of them and the quantification of them and the impact that might have. But in non-communicable diseases, and I'm going to be really vulgar and shift you straight to thinking about that, because that's why we're interested. I don't think we are particularly adroit at thinking about what the externalities are, but there must be plenty. We think about people's choices in relation. Tom does loads of work on takeaways, but actually, an individual's choices about whether or not they use takeaways will influence whether there are takeaways. But
I talk about the meals?
Or even economically, if everyone shunned them in the extremists, there wouldn't be it. And the same must be true if we think about the externalities of, your behavior now and other people's behavior and the impact of NCDs on what that does to the health system and the fact that you have to pay taxes. So my question is, how much work is going on about really thinking about externalities in relation to non-infectious disease? Very long question, sorry, but you know what I mean.
So one of the big fields within health economics is on obesity, and most of that work doesn't work directly with externalities, but more of the economic consequences of obesity on the health sector. Now, I know that there's work because one of our previous PhD students, who's now at Northwestern, Brian Reich, she looked at models where people's perception of what is a healthy look can be influenced by peer groups. So this is a clear externality if you're in a population where being obese is not something that is being frowned on. This might be, more conducive to being obese. So you can think of it as a kind of a copycat behavior. So I know that there's stuff like that, but I think you're absolutely right in pinpointing that the externalities are easy to identify when there's communicable disease, and much less so when there is not.
But they must be central to the issue.
I'm not going to deny that, but I haven't thought about it long enough to say something very coherent.
Well, maybe that's something for the future. Martin, did you want?
Well, just on the question of externalities, I guess one of the big, so I'm interested in diet, and in particular in how the food system, commercial food system, diet. One of the big issues we're concerned about, I suppose, is that the food system, the commercial food system, does not take into account externalities. One of the key externalities is health. So in other words, the health damaging effects.
So are you thinking of access to healthy food in certain neighborhoods? Is that kind of thing?
Just throughout the whole food system. So not just necessarily the neighborhood level, but across. If you take, for example, supermarkets or takeaways or whatever, the balance of healthy to less healthy food and so on. So we have whole sectors of the food economy that are producing food that we know is bad for you. So there's a big externality there, which is totally ignored and not costed in. So if it was costed in, then unhealthy food would cost more than healthy food.
Indeed.
And as would food production that damages the environment. The environment's not better.
Oh, yes. Think of antimicrobial resistance and antibiotics in chicken production,
And then there are social costs. So that, there's that, as well as at the individual level, there's that whole other set of externalities, which I think are really important in relation to the kind of work.
Yeah.
Can I ask you a technical question?
Absolutely.
When you go beyond your simple model, which was ridiculously simple.
Yeah, I agree.
Are you using like agent-based modeling?
I am not particularly, but I do simulations.
Yeah.
So do simulations.
Agent. I just wondered.
No, agent just means decision maker or individual.
I just wondered how you're doing.
Agent-based model, I would say, is somewhat controversial within the field. There are some bits of the discipline that have taken them up, and other people who are very, very reluctant to do so, for philosophy of science reasons.
Okay.
Yeah.
Well, we can have a conversation.
Yeah, I'd be happy to talk. By the way, I should mention I've been here before. I was on a treadmill in somewhere in this building at some point on some experiment.
Well, we're grateful. You were part of the, not experiment, I suspect you were part of the Fenton study.
Yes, that's right.
We're one of 12,435 people. You shouldn't have identified yourself. We don't know who you are within those. We'll keep that quiet.
Thank you.
But thank you.
No, thank you.
Yes, sir.
I was just wondering about your thoughts about when you explained about the sort of the value of prevention. Easily, I would have assumed that people value treatment higher than prevention. If I think about people going to the doctor with a cold, thinking they'll get antibiotics. Can you just explain that? Why you're assuming they're both value gold?
So remember, I didn't actually make any statements about treatment versus prevention, because I kind of shut off one of them and focused on one at a time, right?
I'm just thinking in terms of treatment, I would assume that people always want to be treated, so they're always seeking treatment, so they are they're valuing.
Oh, I get it.
Higher than it actually can benefit society.
Oh, I see. You. Okay, I think I get your point. So this is the one here. No, that's fine. So what you're saying is that people want to treat themselves more than society would. Yeah. That could be for some diseases, but when there are strong externalities, that will typically not be the case. So it's the externality that drives the wedge between those two. And remember also that I made another heroic assumption here, which is people are homogeneous. Everybody's the same. That means everybody's willingness to pay is the same, which means everybody has the same income and the same preferences. It's quite possible that somebody might think, paying £50 for this treatment is peanuts, and for another person, this is the same as a weekly budget for groceries. And so the willingness to pay might be very different across individuals. So this is another thing that I completely disregarded. Yeah. So the key here is the externality. And if there's no externality issues, then there's no reason why these figures should be ranked in that way. Yes, please.
So how would you treat like an anti-vax movement in this context? Is it that
you need psychologists? You don't need economists.
well, is it now that you just have a large segment of society that are essentially irrational actors, or is it that you've just got a larger?
It's a very good question. So it brings me a little bit out of my comfort zone in the sense that I assume here that everybody's rational and they understand the situation they're in. What you're now asking me is going beyond the basic model of rational behavior. Now we can discuss whether people are irrational or whether they're rational within a world that is just misinformed. I'm sure that they're doing the best that they think they can do given their understanding of the world, but we might disagree on what their understanding is. So I don't have much to say about that, other than to point that there are many, many dimensions in which that kind of thinking is now prevalent. It's not just in the context of, it used to be just the moon landing, right? Or Elvis being spotted. Now is anti-vax. So I think that that's a broader phenomenon of yeah.
I assume you can estimate that prevalence in the population and put it into the model. So
of anti-vaxxers. Yeah.
So
well, yes.
5%.
Yes.
Feed it in.
No, absolutely. So that is fairly straightforward to do. Now you just have to make assumptions about how many people you think are in that category, right? No, it's a matter of mathematics. That is very straightforward. I thought it was a deeper question about how to understand that these people think that way, and that's something I'm not qualified to answer. Yeah. Yes, please.
So I'm thinking of it in terms of sort of prevention to do with physical activity and built environment. So the cost.
Prevention of what?
Prevention of diseases like
heart
disease, diabetes, stroke.
Okay, non-communicable ones.
Yeah, non-communicable.
Yes.
Because the benefits and the costs are paid by completely different groups. So buildings have to be safe. Is it just that the lines wouldn't cross?
I think it's too general for me to. You're right in the.
this is a typical, this is a universal public health problem.
Yeah.
The costs and benefits fall on different sectors.
That's right. So let me say it this way. If you're a social planner, you're the one who pays, and you're not the one who suffers, but you're behaving as if you are the one who suffers. You're creating a welfare criterion that, in principle, reflects the benefits or the costs to the population of some disease or something like that. So that's kind of inbuilt in the problem of the social planner. Now, in practice, but that you should think of it only as a benchmark. What would be the desirable thing to do if you were the one who had both the costs and the benefits you experience? Now, in practice, we fully know that this is not the case. For example, in all my derivations here, I assume that the decision maker, individual decision maker, was the one paying for the prevention or the treatment. But we know for many treatments, you go to the GP and they prescribe it and you don't pay anything. So of course, in practice, it's not as simple as that. Yeah.
That's the kind of fundamental public health problem, is that the costs in terms of disease fall on the NHS. Preventive activity is generally paid for by national or local government separately, so they're entirely different budgets.
The health sector.
The cost is paid for by like people building roads, which is nothing to do with that.
Yeah, that's what I'm saying. National, local government.
But that's also one of the reasons why we have externalities, because the people who are actually doing things are not the ones that actually experience the consequences of that. So that's actually a field that is very important within health economics, to look at the institutional features of the health sector and look at the incentives of different decision makers. And that's something that I'm not an expert on. I do stuff about health, but in a very specific way that is not very heavy on institutional detail. This is fairly abstract still. There are people who work on that kind of thing, but just not me. Yeah.
I think I'm going to make it even more complicated.
Yeah.
One of the problems that we struggle with when making an economic case for prevention is that the benefits are delayed into the future, whether it comes to today. I was kind of struck by your conclusion that prevention becomes more and more worth it as prevalence goes up.
Yeah.
But actually, we're really struggling to make that case. I'm not quite sure.
So there's one thing that is buried there that was not apparent because I didn't show you the maths. But there's the issue of discounting. I'm assuming discounting here, which of course I completely put under the carpet. I'm assuming that if there's no discounting, then you would not want to delay the onset of prevention.
Right, but if there is discounting, then just the benefit
it will come down.
Yeah, okay.
Exactly. But you're exactly right. I mean, stuff that is intangible and come in the future, it just is not so present in our current decision making. Just think of global warming or climate change. It's very, very difficult to make these arguments.
But often in health, when it comes to it, and we have to put in a discount rate for future benefits, it becomes it just wipes everything out, and we go, oh, it's too.
it's not worth it.
Coming back to the individual,
We kind of ignore it. It's terrible.
Jean's done research on this in the past. This kind of future discounting by individuals is quite strongly socioeconomically.
It's
socio-economically patterned in the population. So poorer people have a different future orientation than wealthy people. So do you take that kind of socioeconomic pattern?
So no, this is something I've completely disregarded here. Again, completely. I mean, so just let me lay another layer of complexity, which is that even if you knew what individuals, how they trade off current versus future, how do you aggregate across them into a social welfare criterion? It's hugely difficult. And this is an ongoing research project within economics that has grown out of the Stern Review and what have you in the context of climate change. And I think it's fair to say that there is just violent disagreement about what is the right way to do it. Partha Dasgupta, who is a colleague of mine at the Faculty of Economics, has done important work on that, where he shows that there's a difference between the discounting within the life of an individual and across generations. There's no need to assume that this is the same discount rate. That, as a social planner, we are just looking at different timescales, and it's not appropriate to use the same as that of an individual. So this is a very tricky question that I have not given too much thought to. Yeah, please.
on this, is sort of touching upon whether you use any theoretical models to kind of underpin the assumptions and rationale around these, because if you were to do it from an economic perspective or public health perspective, it would be very different, I'm sure, the assumptions made. But could you apply things like game theory to
Yes.
sorts of models?
So one of the 40 slides I skipped was actually the game theory bit. So let me just give you an idea of one thing that is so you remember this idea that that your value of treating yourself is a function of how your probability of reinfection was in the future, and that if it's high, then you are less likely to do it. Okay, so let's just think about it in terms of game theory. Suppose that what happens is, if you look at it in a game theoretic sense, you have what is called multiple equilibria, and the reason is as follows.
You have what was the word you said?
Kids. Multiple equilibria.
Yeah, that bit you said it very fast.
Oh, sorry.
I didn't catch what you said.
I thought you were talking about kids. I have 2 of those.
No. That's nice.
Yeah.
I just didn't catch
No,
what you
because
said.
that's fine. So there's there are lice in the after school club, and you get the email, and your kid has lice, and you're thinking to yourself, should I go through the whole thing with the stinking shampoo and the comb? Okay, it's kind of unpleasant, but you do it. You do it until you realize that all those other damn parents, their kids also have lice, and they're not going to do it to their kids. So that means that if they're not going to do it, what's the point of you doing it? Because the kid is going to go back and get it tomorrow, and then you have the same problem tomorrow. Now, if you're confident that everybody's going to do it, you're going to do it too, right? Because now it's worthwhile. If you all do a concerted effort to get rid of this thing, then everybody's going to be better off. So why do we have multiple equilibria? There's one equilibrium where everybody just does nothing, and it's privately optimal given what everyone else is doing. You can't do anything better than what you're doing. But by the same token, if everybody manages to coordinate on doing the right thing, then you also want to do the right thing. So this is exactly something that comes up in the context of treatment, but that doesn't happen in the prevention world. Now, in the prevention world, how does the game theory work there? In the game theory, so in the same sense that you want to do the same thing as other people when there's treatment, when it comes to prevention, you want to do the opposite of other people. So other people protect themselves. It's great. That means you're less likely to be infected. That means you don't need to protect yourself. Okay, and that's exactly what the anti-vaxxers are basically benefiting from. Everybody else is getting vaccinated. Hopefully we get herd immunity, and that means that the few people don't need to take the jab and risk the tiny side effects that might happen. So again, if you look at a game theoretic version of these models, you get these very weird things that is different from one instrument to the other. So there's lots of game theory in the background once you look at decentralization, but I just didn't have time to go through that. Yeah.
Okay, so I think if there are no further questions, well, thank you for. I think you were very, courageous in coming and talking to us when we have very distinct interests to yours. But the talk's been really fascinating, and I think we've learned a lot. And I'm sure there are some synergies that we can discuss.
I'm always very happy to talk.
So thank you very much, Flavio.
Thank you very much.